Logarithms introduction. So, logarithms are designed in order for us to help to deal with the exponents. So if we have a problem like this, it's fairly simple because we can think 5 to the x is equal to 25. Well, we know 5 squared is equal to 25. So therefore, x is equal to 25. We get to that exponent, or x is equal to 2. Excuse me. We get to that exponent by just changing the bigger number down. Well, sometimes it's not that simple. So let's say we have 6 to some power is equal to 27. Well, I don't know what I can raise 6 to in order to get to 27. There's not a number that's easy for me to check with. So I can use the calculator and I can keep trying different exponents, and eventually, years later, I might find it. But luckily, there's something that can help us find these, and that's called logarithms. So log help us solve for the exponent. So this will convert from 6 to the x equals 27 to log base 6 of 27 is equal to x. And so you can see how these relate. The exponent from the original problem shows up on the very far right-hand side. The base stays as the base. So the base over here is the same base that you have here. The next spot I always call the answer spot, because I have lack of a better word. So that answer portion now switches spots. Now, I use a fish to convert between my logarithms and my exponential, and it works either way. If I want to go from exponential to logarithm or logarithm to exponential, and it fills into the positions of those 3 spots, starting from the left and going to the right. So you start at the base, circle around to the opposite side of the equal sign, and come back through whatever's next to the base. Now, why do we have logarithms? Are these actually used? Well, exponential problems are used often in growth and decay problems where we see a quick growth or a quick decay, like in bacterial growth or radioactive decay, or hopefully if you're looking at compounding interest, you're looking at there's actually a exponential growth in that. But logarithms are actually used all around us as well. And it's important to understand how these work so we can understand how things like the Richter scale, which measures earthquake impact, and the decibel system, which measures how sound waves impact, or how powerful sound waves are. Those two things are done off of a logarithmic scale of base 10. So the common log is written like this: log. There is no base written, and there's a big number up here. That base is understood to be base 10 because we count in the base 10 cycle as you go from 0 to 9, and then you repeat for 10 through 19, 20 through 29, and you keep repeating in that cycle. So the common log is in base 10, just like our counting system is. Let's work through a couple of logarithms and see if we can come up with the answers. So this first couple, we're just going to be identifying what the exponent is. And so step 1 is going to be deficient. So we take it and fish through the exponent, from the base to the exponent, and then we're going to work it. 4 to the x is equal to 16. So 4 to the second power is 16. So I rewrite the 16 as 4 to the second. So x is equal to 2. That's your answer. One more. Starting with the base, circle through the exponent, and come back to the answer. So 7 to the x is equal to 343. This may not be one you know off the top of your head, but if you think back to the problems I gave you earlier this year when we were working with memorizing for factoring, that's one of your cubes, and that's 7 cubed. So if we match x and exponent, our answer turns out to be x is equal to 3. Now, on these first couple, the base was smaller than the answer. On these, you'll see your base is bigger than your answer. And that means that you are going to have some type of radical. And if you need a refresher of those exponent rules for radical exponent, or radicals, which are going to create fractional exponents, or for negative exponents, there's another video attached to this lesson. So let's go starting at the 36, going through the x and back to the 6. So when I rewrite this, this is 36 to some power is equal to 6. If I do 6 to the second is equal to 36. And so that's 6 to the second to the 2x is equal to 6 to the first. Now I can set my exponents equal to each other. So 2x is equal to 1. Therefore, when I solve this equation, x is equal to 1/2. That gets you back to that 1/2 power that you would have had originally if you would have just identified that 36 to the 1/2 is 6. Let's do another one of these. 8 to the x is equal to 2. 8 to the x power is equal to 2. So 8 is 2 cubed. So 2 to the 3x is equal to 2. Set our exponents equal to each other. 3x is equal to 1, and therefore x is equal to 1/3. And again, on this one, if you identified that the cube root of 8 is 2, and you went x is equal to 1/3, that is okay. That's a shortcut. Now, this next one, we are going to be working with trying to identify what will create these unique answers. So here we have a fraction with the number in the denominator. That means we need to figure out how we can get it down there. So 5 to the x is equal to 1 over 125. Well, how can I convert this into 5 to a power? Well, that means this is 1 over 5 cubed. And that means that we have 5 to the -3rd. And if you forgot your negative exponent rules, that's in that exponent explanation that I gave you as well in addition to this lesson. So if we set our exponents equal to each other, we have x is equal to -3. Now this next one may take you a little bit more thinking. Square root of 7 to some power is equal to 49. So the square root of 7 to the x power is equal to 49. So the square root of 7, we're trying to figure out how we can get from there all the way to 49. Well, if I have the square root of 7 times the square root of 7, that gives me a 7. If I have the square root of 7 times the square root of 7, that gives me a 7. And so if I multiply those two, it gives me 49. So it takes me 4 square roots of 7 to get to 49. So that means x is equal to 4. Now, another way you could have thought about this is square root of 7 to the x is equal to 49. Let's say 7 to the 1/2 power is equal, 7 to the 1/2 x is equal to 7 squared. And if I set the exponents equal to each other, I end up with 1/2 of x is equal to 2. 1/2 of something is 2. What would that something have to be? Well, half of 4 is 2, so x is equal to 4. That's your answer. So these next set, we are solving and the x is in a different spot. X is here. So it's no longer on the answer side. It's no longer on the side by itself. These are actually the easier ones to solve because once we fish it, so we have log base 27 of x is equal to 1/3. So we're going to fish it. That means that 27 to the 1/3 is x. Well, if we think back to our exponential rules, 1/3 is the cube root. So the cube root of 27 is 3. Some of you are going to go, oh, I don't remember that. Well, type that in your calculator. Just make sure to put parentheses around your exponent to keep it all grouped together. So let's do the next one. Log of 1/3 of x, log 1/3 of x is 4. So let's fish it. 1/3 of 4 is x. So 1/3 raised to the 4th power is x. So 4 1/3s multiplied together gives you 1/81st. The way I picture to get that 3 multiplied that many times is I go 1/3, or 3 times 3 is 9. And I have 2 of those sets, so 9 times 9 is 81.